Hello and welcome to the new unit polynomial functions, and in today's lesson we will see that how can we explore polynomial functions. So let's talk about polynomial functions first. The word poly means many. So any function that consists of a number of terms is termed as a polynomial function. For example, in this equation 1, this equation 1 gives us the general representation of a polynomial function, in which we can see that we have number of terms separated by this arithmetic operation, addition. Okay, so now for this function here, this an is called the leading coefficient. Is called the leading coefficient. Here n represents the degree and a naught is your constant. So remember that whenever we have a polynomial function, a n cannot be equal to 0. Like the leading coefficient can never be equal to 0. And the constraint on the exponents are that they always have to be whole numbers, and the coefficient are always real numbers. So the degree or the power always has to be positive, the exponents are always whole numbers, and the coefficient are always real numbers. So in an xn, this number is called as constant and xn is the variable. So its degree always has to be positive, or the exponent always has to be positive, and this coefficient or the constant term always have to be a real number. It cannot be a variable. Okay, so when we have written a polynomial function, it always has to be in the standard form. And in a standard form, what do we mean by standard form? That when we look at the degree always has to be in the descending form or the descending order. We start with the highest and move down to the lowest, in which the constant or the variable with the power 0 comes at the last, because any variable with power 0 equals 1. So now in this example, 4x cubed plus 3x squared plus 5x minus 2, this 4x cubed is called the cubic term. And why will we call this cubic? Because the variable here has the degree 3. Based on the degree 3, we say that it is a cubic. Now because of this x2, this term is called the quadratic term. Because of the power 1 here with the variable, it is called the linear term. And because of this 2 here and x to power 0 here, we have this 2 to be as the constant. So how can we classify a polynomial? Now to classify a polynomial, we need to look out for two things. One is its degree and the other is the number of terms. Now for example, in the previous example, we saw that 4x cubed plus 3x squared plus 2x plus 1. We term this, the first term or the leading coefficient term, as the cubic term. Why? Because the degree of the variable here was 3. This was the quadratic term and this was the linear term. Okay, so based on the degree we can this is how based on the degree we classify a polynomial function. And based on the number of terms, if we count the number of terms, I told you that we can count the number of terms based on this arithmetic operation, addition. Whenever we have this polynomial function and we have some arithmetic operation like addition or subtraction, we say that we have different terms there, because in this we have this first 4x as the first term, this 3x as the second term, this 2x as the third term, and this one as the fourth term. So let's see that how the graph of the function also change based on this classification. Now let's first look at this table here, and in this table we see that when the degree is 0, like in this example of the polynomial function 5, we see that it has a variable here with the degree 0. So based on that, we say that it is a constant term, and because the number of term is 1, it is termed as the monomial. Okay, so monomial can be a real number. Whenever we have a monomial like 5 or x, it is a monomial because for the monomial we can have either we can have a constant term, or we can have a variable term. Okay, or we can have a product as well, like 2 into x equals 2x. This is still a monomial. Okay, but the exponent always has to be a whole number. Okay, remember this, the exponent always has to be a whole number. There is no exception for that exponent here. So moving on to the next one, that is when the degree is 1. When the degree is 1 of the variable, it is called the linear function. When the degree is 2, it is called quadratic. When the degree is 3, it is called cubic. You name the polynomial function based on the highest degree always. Okay, and then the degree is 4. But if you're looking at the individual terms, like in this case, we can name them individually as well based on the degree and based on their degree. But overall, if you are naming the function, you have to look at the highest degree. So this is quadratic, and this is quintic because we have a degree 5 here. Now, and if we see that based on the number of terms, because it has one term, it is called monomial. It has two terms, binomial, one term, monomial, 1, 2, 3 terms, trinomial, 2 terms, binomial, and it consists of many terms. You can say it is the polynomial with 4 terms. So based on this classification, their graphical representation also change. Whenever we have a linear function, and by linear function we mean that a variable with power 1, we always have this we have this graphical representation like we have here in the form of a line. In case of a quadratic function, when the degree is 2, we have this parabola shape. Okay, in case of a cubic function, x cube, we have this shape in which we have a maximum and a minimum point. We have this curve shape like this. And in this quadratic function, we have this form of representation, and for quintic function we have this representation. So the graphical representation will also change based on their degrees. So now in this example, let's look at a couple of examples here, and we will see that how can we classify the terms based on their degrees and their number of terms. So in this first example, you can see that f of x equals minus 2x cubed plus 5x plus 8 here. Because we have the highest degree to be 3 here. Okay, so we say that its degree is 3 and it is a cubic function. Okay, now but is it a polynomial function or not? For it to be a polynomial function, we know that what are the conditions? Two conditions. The first condition is that the variable always has to be, or you can say that the exponent always has to be a whole number, and the coefficient always has to be a real number. So we can see that in all of these terms, the exponent are always whole numbers, they are positive, and the coefficient are always real number. So it is a polynomial function. The degree is 3 because the highest term here is of x cubed. So the degree is 3 and is called a cubic function, and the leading coefficient is the term with the constant term with the highest variable. Like in our example, we have this 2x cubed, right? So this term with the x cube, the coefficient term or the constant term of the x cube is called the leading coefficient here. It is negative 2. So in this next example, let's see if it is a polynomial or not. So all the terms here are real numbers, right? And the exponents are all whole numbers. So it is a polynomial. What is the degree? Let's look at the highest term here. So you can write it in the standard form first with the highest degree, then the lowest and the lowest. So the higher degree is 4, so it's a quadratic function with degree 4. And what is the leading coefficient? The term with the 4, that is negative 2. So negative 2, not 0.8. Okay, negative 2. and the last one xk plus 3x, so you can see that here that it is a polynomial or not. So it is not a polynomial because the last term here we have this 3x here, so this term does not have a variable base. Okay, this base is a constant. The base cannot be a constant, it always has to be a variable, and the exponent here is not a whole number. Okay, the variable we have a variable in the exponent, and that cannot be the case because x can be equal to -1 or whatever. We don't know the value of x. That is why the third term is not a polynomial function. So that's it for today, and thank you for joining.